In the first problem of the video, we will be learning about increments and differentials. What we need to know about these two is that you need to be able to differentiate them, each one from the other. When they ask you to find the increment, they will be asking you the exact value or to calculate. Here is when you have to find the difference, the delta, of the two values given. First the final and then the initial. And when they're asking you to find the differential, you need to do the difference of the value given and then f prime of that times the difference in the radius that you would have. So here, for example, if they're asking you to find the difference in volume, then you would have to do the difference in volume times the equation that you have given, that is prime of that equation, so this equation is differentiated, times the difference in a radius, for example, in a cone. And here they will be asking you to estimate. So this will be, a differential will be an approximated value. And between these two, you will have a small difference in the decimals, but they will be very close between each other. So right now, in the next problem, we will be learning about increments and differentials, and we will be seeing when they ask you for an exact value or an estimate.
A solid steel cylinder has a radius of 5 centimeters and a height of 10 centimeters. The formula for a volume of a cylinder is pi times radius squared times height. Here it is asking us to find the real change in volume. You will need to find the exact difference in volume. To do so, you will need to subtract your final volume minus your initial volume. Your second volume equals to pi times 5.1 centimeters, the final volume, squared times the height that stays constant. So your final volume should equal to 2,601 over 5 pi. And your initial volume is pi times 5 squared times the height. And volume 1 equals to 500 pi. Now what you do is you subtract the final volume minus the initial volume. So 2,601 over 5 pi minus 500 pi, which will equal to 101 over 10 pi, which is approximately 31.7301 centimeters cubed. For this section, you will need to recall the values for the final and initial volume. Because it is asking us what is the percentage change, you will need to find the absolute value between the difference in the volumes divided by the initial volume times 100. Now that you've placed each value in the correct term of the equation, you multiply it by 100 and you will get your percentage change as 2.02%. To find the approximate change in volume, you will need to use differentials to solve this part of the problem, as we mentioned before. You need to remember that the formula we used to calculate the volume of the cylinder was volume equals pi times radius squared. Now you need to differentiate the volume to get the f prime in the equation, and f prime equals to pi times 2 times radius times height. Also, you must multiply it by the difference in radius. To do so, you must subtract the final radius minus the initial radius, leaving a difference of 0.1. Finally, to calculate the estimated change in the volume, we must multiply the derivative of the function times dr by plugging in the initial values on the formula. you must multiply pi times 2 times 5 centimeters, which is the initial radius, times 10, which is the constant height, times 0.1. As you can see, the answer is 31.4159 centimeters cubed. For this section, you will need to recall the values for the real change in the volume and the estimated value for the change in volume. To find the percentage error, you will need to find the absolute value of the difference between the estimated change minus the real change divided by the real change in volume times 100. Your percentage error equals to 0.9902%.
Now, what we will be learning in the next problem, we will have to solve an indefinite integral. What this means is that you will be having to find the antiderivative of the equation. For this, we have our equation of the integrand of f of x times dx, which equals to the antiderivative of f of x plus c. This is our formula that we have. And also what you need to know is that to convert it to its antiderivative, any constant that you have inside the equation, you will have to add the exponent plus 1 and divide it by that same number, plus c.
In this problem, we will be solving it by antiderivatives. The first thing you need to check is if you can simplify. Here, what we have to do first is distributive property in each term of the equation. After you've simplified the whole equation completely, you start doing the formula that we reviewed earlier to add a 1 to each exponent to start finding the antiderivative of each term. Once you do that, you eliminate the integrand of the equation and start adding the ones, as you can see, in each of the terms. Don't forget to simplify correctly, because if not, the whole equation can be wrong. The n stands for the number that you're adding the 1 to, and then you divide all of that addition by its coefficient. Here what we are doing is a process of tortilla to simplify. Don't forget to add your plus C. And always simplify completely. And now you have your antiderivative.